All right, now we're moving on to 12.5, congruence and similarity. Similarity, okay? Congruent polygons are polygons with the same size and the same shape. Super key, same size and same shapes. Triangles ABC and DEF are congruent. This statement is represented symbolically as triangle ABF is congruent to triangle DEF. So this symbol means is congruent to. If you could lift up triangle ABC and place it right on top of DEF, the angles and the sides would coincide. What that tells us is that the measure of angle A is equal to the measure of angle D. The measure of angles C and F are equal to one another. And the measures of angles E and B are equal to one another, okay? That also tells us that AC is equal to DF, FE is equal to CB, and AB or BA is equal to DE. Okay, matching angles are called corresponding angles. Matching sides are called corresponding sides. Okay, so corresponding angles are angles that have the same measure, and corresponding sides are sides that have the same measure, or are segments. You can call those either of those, okay? Are segments that have the same length. The table below lists the congruent parts of the previous congruent triangles. To indicate that the corresponding angles and sides of two figures are congruent, you mark the corresponding parts with that congruence symbol, okay? So this is what we just walked through with the angles and the sides in those triangles on the previous page. When you write an expression like triangle ABC is congruent to triangle DEF, you must list the vertices of each triangle's corresponding angles in the same order. This way you will be able to tell from a statement of congruence which parts are congruent, even if you don't have a picture available for you, okay? For instance, given the statement triangle PNR is congruent to triangle WAQ, you would know immediately that angle N is congruent to angle A because each is the second vertex in the names given for the triangle. See, you have N in the middle here, and you have A in the middle there. Likewise, you would know that segment NR, okay, this segment right here, segment NR, is congruent to segment AQ since they are the last two letters in the names of the triangles containing them. So, example number 1 says triangle RST is congruent to triangle XYZ. Complete each statement. Angle R is congruent to what? Even if we didn't have these pictures available, we would be able to figure this out simply from this statement of congruence right here. Angle R is congruent to, well, angle R is the first angle listed in our triangle on the left, so angle R is congruent to angle X, okay? So angle R is congruent to angle X. Angle S then is congruent to angle Y, and angle T is congruent to angle Z. How about our segments? Segment RT is going to be congruent to segment XZ, okay, to segment XZ. Segment RS is congruent to segment XY, and segment ST is congruent to segment YZ, okay? There's some statements of congruence. Skill check number 1. Triangle QRS is congruent to triangle TUV. Complete each statement. Angle Q is congruent. It's the first angle on the left. It will be congruent to the first angle on the right. So angle Q is congruent to angle T. Segment RS. Here's where it's listed, the last two. So it will be congruent to the last two on the right. So congruent to UV, okay? Number 3, the measure of angle S. Here's angle S, the last angle, so it's going to be congruent to the last angle there. So angle S is congruent to angle V. Just erase these. Okay. Segment QR, first two, it's going to be congruent here to TU. That should have a line segment over it. Okay, so should that. Angle U, middle angle here, going to be congruent to the middle angle over here, angle R. And then TV, first and last, okay? TV is going to be congruent to QS, segment QS. All right? Continuing right along, just as two triangles can be congruent, so can two quadrilaterals or any other pair of polygons with the same number of sides. Congruent means having exactly the same size and shape, whereas similar means having the same shape but not necessarily the same size. Okay? Definition, okay, of similar polygons. Similar polygons are polygons that have the same shape but not necessarily the same size. This one wavy sign means is similar to. The corresponding angles of similar polygons are congruent. That means corresponding angles in similar polygons are the same measure. However, the sides will be proportional, not necessarily congruent, not necessarily the same. So sides, corresponding sides in similar polygons are proportional. Corresponding angles in similar, polygons are congruent. Suppose two triangles are similar and a side of the larger triangle is 3 times as long as the corresponding side of the smaller. The same will be true for the other two pairs of corresponding sides. This leads us to a theorem that we apply in geometry. If two polygons are similar, then the corresponding angles are congruent and the lengths of the corresponding sides are proportional. Here, we have two similar triangles. Their corresponding angles, you can see, are congruent. They are the same. Their corresponding sides, however, are proportional to one another. They are not the same, but they are all in the same ratio to one another. When stating that two triangles are similar, list the vertices of each triangle's corresponding angles in the same order, just as we were doing before. In the figure above, triangle ABC is similar to triangle DEF. That means their corresponding angles are congruent. They are the same measure. It also means that AB, so segment AB, is similar to not similar. Side AB, or segment AB, the ratio of AB to its corresponding side in the similar triangle, DE, is 6 over 4, which reduces to 3 over 2. Take a look at the ratio of AC, which is 12, to its corresponding side, DF. That is 12 over 8, which reduces to 3 over 2. Then look at side BC and its ratio to EF. Okay, that is 9 to 6, which is also 3 over 2. Notice that the ratio of the corresponding sides is a constant 3 to 2 for these similar triangles. This ratio, this constant ratio for the corresponding sides of the two similar triangles in this case, is called the scale factor. If you know the lengths of the sides in one of two similar triangles and the length of one side in the second triangle, you can use proportions to find the remaining two sides of the second triangle. So here we have an example number 2, triangle RST is similar to triangle XYZ. Use a proportion to find XY. So what we're going to do is we're going to set up a proportion where XY to the relationship of xy to its corresponding side, RS, is going to be equal to the relationship between, and now you pick two sides that you do have measurements of, XZ and its corresponding side, RT. So the ratio between XY and RS is going to be equal to XZ to RT because these two triangles are similar. Now we can plug in what we know. XY is what we don't know. RS is 9. XZ is 12. And RT is 18. Okay? Now, our book went ahead and simplified or reduced 12, 18, okay, to just make this a little simpler. XY over 9 is equal to 12 over 18. Both of those are divisible by 4. Or, excuse me, no, they're not. Both of those are divisible by 6. 2 over 3. So XY to 9 is equal to 2 over 3. Now, you apply your property of proportions, which we've talked about before, where we're cross-multiplying, where 3 times xy is equal to 2 times 9. 3 times xy is equal to 18. Divide both sides by 3, and segment xy is equal to 6. Okay, so xy is equal to 6. That should be in the same proportion. 6 over 9 is equal to 2 over 3. Okay, 12 over 18 is equal to 2 over 3. What about the sides we didn't tackle? YZ and ST. YZ is 10. ST is 15. When you reduce those, that's 2 over 3. They all have the same ratio. They are proportional, okay? The proportion was set up with both ratios in the order side of smaller over corresponding side of larger. The reduced ratio of corresponding sides was 2 to 3. If the proportion had been set up with ratios in the order side of larger over corresponding side of smaller, the reduced ratio of corresponding sides would have been 3 to 2, and xy would have been in the denominator of the other ratio. Either way will yield the correct answer, but the key, you guys, is that you have to keep both ratios in the same order. So if you're going to do small to large, you have to keep all of your ratios small to large. You can do large to small, but you have to keep all of your ratios large to small. You can decide, okay? Skill check number 2, we've got some triangles. If triangle PQR is congruent to triangle STU, which side corresponds to the given side? So number 1, PQ, here's PQ. That corresponds to ST, right here. Okay? SU, okay, here's SU down here. That corresponds to PR. And then we have QR right here, and that corresponds to TU. Which angle corresponds to the given angle? Angle S corresponds to angle P. Angle Q corresponds to angle T. And angle U corresponds to angle R. Use proportions to find the missing lengths. So find PR. PR is to SU as PQ is to ST, okay? Notice I did smaller over larger is equal to smaller over larger. Fill in what we do know. PR is what we don't know. I'm just going to call that X, okay? X over SU is 6 is equal to PQ is 8 over ST is 12. You guys know I would rather you be working on these vertically, top to bottom, but I'm running out of space on the bottom of my page, so that's why I'm doing it left to right. So x over 6 is equal to, and I'm just going to reduce this ratio, 8 over 12. Those are both divisible by 4. So x over 6 is equal to 2 over 3. 3x cross multiply is equal to 12. So x is equal to 4. So PR is 4. You work through those same steps for TU. I'm not going to do that for you. I want you guys to practice do that. You should get 9 for TU. Okay? And that's this lesson.